So here we have third problem, week 8, chapter 13. Magnetic field perpendicular to single wire loop of diameter 10 centimeter decreases from 0.9 Tesla to 0 Tesla. The wire is made of copper and has diameter. How much charge moves through a wire while field is changing? Okay. So basically we have a wire, this one. So it has a diameter on it. Let's say this is diameter capital D, and then we have a wire. It has inner diameter, so I call it D, and it has a length L. Okay. Also the magnetic field is given, so B initial is 0.9 Tesla and B final is 0 Tesla. Capital diameter of the loop is given, and this is copper, so it has a resistivity of copper, and small diameter of the wire, and then we have the length of this wire. Okay, so we have to find how much charge will be moving in this wire while field is changing in the loop. Okay, so let's start writing the formulas. First of all, we know that EMF is equal negative of the magnetic flux over dt, correct? And we also know that it's equal to the d area B over dt, and we also know that area is a constant, so dB over dt. Okay, so let's keep it like this, our first equation. Then we have another formula where the current is equal dq over dt, correct? Which is also equal to the EMF over R. Now, first of all, how can we get area of this loop? So the area for this loop is actually pi R squared or pi d squared over 4, correct? So let's write it down. So, okay, so it's like this one, and by taking this equation, we can say that dq is basically equal EMF dt over R. Okay. Now, then we also know that we have dB over dt. Okay, so let's plug this first equation in the second equation. Then we get what? dq is equal, EMF is equal area dB, okay, over dt, and we also have R, and we also have dt here. So this dt will cancel out. We have a dB over R. If you want to get total charge, basically we have to integrate from both sides, and when you integrate from both sides, what you get here is, so the area here is pi capital D squared over 4 multiplied B will be B final minus B initial. Don't forget that we still have here negative sign, and that negative sign will be positive because when you subtract from final B, initial B, it becomes negative, so negative with that negative will cancel out. Then after that we have resistor, so the resistance will be equal to the rho L area. Okay, that area is the area of the wire, okay, which is rho of the copper, L pi, this is D small, so that's why I said D small, squared over 4. Okay, Then you bring here that values, so rho L pi d squared over 4. Now it will be much easier if you try to calculate separately top side and bottom side, so that you do not do any mistakes. So finally, when you integrate this one, you will get total Q, which is equal to the pi d squared over 4 times B final minus B initial, and divide by the resistance, which is rho times L over pi small d squared over 4.